All right, so section 4.1 and 4.2 is introduction to matrices and then operations with matrices. Okay, so a matrix is just a rectangular array of numbers. So it's a bunch of numbers in a rectangle. The entry of a matrix is each value in the matrix, so each number in the rectangular array. And then the address is basically where it's located. So a location in a specific matrix represented by the lowercase matrix letter with the row and column number as subscripts. Okay, so we'll kind of talk about that. So number one, it says the prices for different sandwiches are presented in the table. So any table that you do is really a matrix. So when you guys use Microsoft Excel or something like that, it's creating a matrix of numbers. All right, so to display the data as matrix P. So P for prices. So our numbers are $3.95, $5.95, $3.75, $5.60, $3.50, $5.25. It says, what are the dimensions of P? So dimensions are always rows by columns. Columns with an N. All right. Now, if you think of rows and columns, a lot of people get confused on which one's which. All right, I always think of columns as like the columns on a house. So columns are up and down. Rows are this way. Okay, so how many rows do I have and how many columns do I have? 3 rows and 2 columns. You guys see it? So that means the dimensions are 3 by 2. C, what is the entry in P32? So this still goes with rows and then columns. So it's saying what's in the third row, second column. So go down to the third row. So 1, 2, 3. Go to the second column, 1, 2. It's that number right there, 525. Okay, and what did that represent in our original table? The what? The price of a 9-inch tuna sandwich, right? Okay, and then D, what is the address of the entry 595? Okay, so now we're going the opposite direction. We're saying it's going to be P, so lowercase p. And where is 595? Yeah, it's in the first row, second column, right? So it's P12. And that's the address. Okay, makes sense? Okay, so this next page, it says solve y equals So solve y3 equals 3x minus 2, 2y plus x. Okay, so when you have a matrix equaling another matrix, each entry has to match up with its corresponding entry. So basically y is going to equal 3x minus 2. And then 3 is going to equal 2y plus x. Do we know how to solve something like that? Yeah, that's what we did in chapter 3. It's a system of equations. So we know what y is, so let's just replace y with this whole 3x minus 2. So we're doing substitution. So I have 3 equals 2 times 3x minus 2 plus x. I replace my y with 3x minus 2, solve it out. I'm going to add the 4 to the other side, so I get 7. 6x plus x is 7x, so x equals 1. Still need to find y, so go back and plug in. So since y was 3x minus 2, it's 3 times 1 minus 2, which is 1. Okay, so x and y are both 1. Okay, it's not really lines intersecting, so you don't have to write it as a point. All right, so adding and subtracting matrices. So it says to add or subtract matrices, add or subtract the corresponding entries. Okay, so if I have W plus Y, my W matrix is 3, -2, 1, 0. My Y matrix is 1, 4, -2, 3. And when you see matrices, a lot of people do brackets, like I usually do brackets. Some people do like parentheses. It's up to you, it doesn't really matter. All right, so we add our corresponding entries. So this is a 2 by 2 matrix, 2 rows, 2 columns, and this is a 2 by 2 matrix. So that means we're allowed to add them because they have the same dimension. So we're going to end up with a 2 by 2 matrix. Okay, it's real easy to see what this is going to be. Do you guys see that you just add the corresponding ones? So you'd have 3 plus 1, so 4 here. I'd have -2 and 4. So -2 plus 4 is 2. 1 and -2. So I get -1. And then 0 and 3. So 3. That's your matrix. So 4, 2, -1, 3. Okay, let's do one more and then I'll let you go and break. So x minus z. So 4, 7, 2, 5, 1, -1. Minus 2, -2, 3, 1, 0, 4. So it's going to end up being a 2 rows, 3 columns, so 2 by 3, just like both of them are. Okay, so I have 4 minus 2. I'm going to write out the steps. So 4 minus 2 is the first spot. 7 minus a -2. 2 minus 3. 5 minus 1. 1 minus 0. And I'm going to have -1 minus 4. Okay, you don't have to write out that step if you guys see it, but you should get 2, 9, -1, 4, 1, -5. Okay. This is a very easy process, but you'd be surprised on the matrix test. A lot of people mess up on these because they'll just mess up like 2 numbers out of 6. You know, there's a lot of numbers you have to keep track of on these. All right. All right, I'll let you guys go on your break. All right, so the next one is x plus y. So x plus y. All right, so let's go back. So x is 4, 7, 2, 5, 1, -1. Plus y. And y is 1, 4, -2, 3. What do you guys think? There's a problem, right? Yeah. So what's the problem, Kendall? Yeah, this one has 3 columns. So this is a 2 rows, 3 columns. And this is a 2 by 2. So this is not possible. So if you had like a Microsoft Excel program or something, you were trying to add matrices that were not the same size, it would say error or it wouldn't let you. All right, so we know that multiplication is repeated addition. So this is true for matrices as well. So if we have W from above, so W was 3, -2, 1, 0. And I add it to itself, so 3, -2, 1, 0. You end up with 6, -4, 2, 0. That's a 0. So how does that compare to the original W? It's just what?
Double.
It's just double. You just multiplied by 2 on every single term. So multiplied each entry by 2. All right, so that tells us that W plus W plus W. So what do we think that's going to be? 9, -6, 3, 0. Do you guys see how that would end up being true? 9, -6, 3, 0. So W plus W can be written as 2W, therefore you can multiply an entire matrix by a number called a scalar. So that number out front is called a scalar. All right, so if I have 3w minus 2y, so I'm going to have 3 times 3, negative 2, 1, 0, plus 2 times y is 1, 4, negative 2, 3. Okay, so the first thing we do is we multiply by our scalar, just like the distributive property, right? You're going to distribute it into each thing. So when I multiply through it by my scalar, I'm going to get 9, negative 6, 3, 0. And I'm going to add that to 2 times everything, so 2, 8, negative 4, 6. What was that? Oh, it's minus? Oh, yeah, it is minus. I'm blind, sorry guys. So minus. So let's just put a minus in between. Now you guys could do plus and then distribute the negative as well, just like distributive property. Okay, so when I do this, I get 9 minus 2, so 7. Negative 6 minus 8, so negative 14. 3 minus a negative 4. So that's going to be 3 plus 4, so 7. And then 0 minus 6, so negative 6. That's your answer. So 7, negative 14, 7, negative 6. All right, so let's kind of do this one as we go. So if I have 2x, so here's my x. So I'm going to multiply 2 in as I go. So I'm going to get 8, 14, 4, 10, 2, negative 2. And I'm adding it to z. Let me go to full screen here. So I have 2, negative 2, 3, 1, 0, 4. When I add my entries, I get 8 plus 2 is 10, 14 plus negative 2 is 12, 4 plus 3 is 7, 10 plus 1 is 11, 12 plus 0 is 2, negative 2 plus 4 is 2. And that's your answer. Okay. Once again, lots of numbers to keep track of. So as I'm grading your tests, I'll be grading like 6 numbers for each question. So if you make a little mistake, you're missing points. So be very careful. All right, x minus 2y. Okay, so x minus 2y, what do you guys think about that? It's not going to be possible, right? Because x minus 2y, you'd have a 2 by 3 matrix and a 2 by 2 matrix. So not possible. Okay, I'm going to go ahead and look at multiplying matrices today too. All right, multiplying matrices is not as easy as adding matrices. So you would think that you just multiply each corresponding entry, but it's not that easy. It's a lot harder. So matrices A and B can be multiplied only if the number of columns in A equal the number of rows in B. So the product of a matrix with dimensions m by n and a matrix with dimensions n by p. So here's what we're going to do. This is the columns in the first one. This is the rows in the second. You check to see that they are the same number. So see how mine is n and n, so it's the same number. And then we ignore those numbers. So you just make sure they're the same and then ignore them. What's left is the dimensions of your new matrix. So it's going to be an m by p. Okay, so can we find the matrix product A times B if A is 2 by 3 and B is 3 by 4? So we make sure those numbers in the middle are the same. They are, so we're allowed to multiply. So yes. Ignore those numbers. The numbers that are left are your new dimensions. So yes, it's going to be a 2 by 4. So can we find the matrix product B times A? So B was 3 by 4, and A is 2 by 3. So here's an interesting topic. Matrices are not commutative. Do you guys remember what commutative means? Commutative means that you can move things around. Like when we first learned multiplication, we said 3 times 5 was the same as 5 times 3. And we can move those around and it was okay. But with matrices, if you do A times B, it's not the same as B times A. So the order matters. So since these numbers are not the same, it's no, you cannot multiply in that direction. So I'm going to write not commutative. In other words, order matters with multiplication. With addition, it would make sense that you can switch the order and add the entries the same way, right? Addition, it's okay. But multiplication, it's not commutative. Okay, so can we find the matrix product x times y if x is 2 by 2 and y is 2 by 10? Yeah, those numbers are the same. So it'd be a 2 by 10 matrix in the end. Okay. All right, so multiplying matrices. So do you guys know how to like rub your belly and pat your head? Have you guys done that before? Okay, so let's try that. So rub your belly, pat your head. I'm not very good at it. Some of you are very good at it. All right, here's what you're going to do with multiplying matrices. So your left hand is going to go from left to right. And your right hand is going to go from top to bottom. Okay, so take your hands and move your left hand left to right, and then move your right hand top to bottom. And we're going to do them at the same time. So ready? So each time you go left to right, go top to bottom. Does that make sense? All right, kind of confusing. Some of you guys are just kind of connecting your fingers. Some of you guys are like just taking this one and going down and this one and going towards it. All right, left and right. It's like a 70s dance, yeah. You got it?
This one no one can ever get. I can't not do it. Like this one's going up and down and this one's going 1, 2, 3, 1.
Because you're like a director. Okay, so it says in a matrix product, P equals A times B. Each element P, ij, is the sum of the products of the consecutive entries in row J in matrix A and column, that's I in matrix A and column J in matrix B. Okay, confusing. That's why we do the little hand trick. So just remember this method that we just talked about. So number one, it says, suppose we have the following matrices. I'll explain it in just a second. So I have W is 3, negative 2, 1, 0, 2, negative 1. And X is 4, 7, negative 2, 5, 1, negative 1. Okay, first we check to see that we can multiply. So we're going to think about the dimensions. So how many rows and columns does the first one have? 3 rows, 2 columns. Remember, columns are like columns in a house. So this is a 3 by 2. How many rows and columns does the next one have? 2 by 3. So that means we're going to end up with what size? 3 by 3, right? So this is where it's convenient to write these little blanks, and you want to give yourself enough room. I should probably have made that a little bigger, but it's okay. All right, we're always going to do rows and columns, just like dimensions, rows and columns, right? So rows in the first one, columns in the second one. So I circle. Okay, I'm going to go up to the front of the board so you guys can see me when I do this. This is when you're doing your left to right. So first one and the first one. This, since I'm on the top row, so let's say I want this entry over here. So the top left corner. If I want the top left corner, I'm going to use the first row and the first column to find that, because that's the top row and the first column. Okay, if I want to find the middle one in the top row, I'm going to use the top row and the middle column. Do you guys see what I'm saying?
Yeah.
So if I want this one over here, that's in the second row and third column, so I'm going to use the second row and third column to find it. You guys see what I'm saying? Okay, so if I have the first space, I'm going to use 3 times 4, and I'm going to add it to -2 times 5. You have lots of computations just for this first thing. Okay, so let's do it. I'll write out all the steps. Okay, so we were saying if I wanted this row, or this spot right down here, that is in the third row, second column. So you would use the third row, second column to find it. Okay, that's what I was saying. All right, so I want this first spot. So I'm going to use the first row, first column to find it. And it's a lot of computations. I'm going to take your fingers. I wish I had a little, so I'm taking, I don't have like a little pointer or anything. No. All right, I'm taking the 3, that's my first one, and multiplying it by 4. So take your fingers and do that little trick I was showing you. So that's the first spots. Now move your left hand over 1 and your right hand down. So now I'm going to do -2 times 5. And I'm going to add them. See, I told myself I should have given myself more room. Okay, that's the first spot. Give myself more room. Okay. Now what? So now I want the second spot. That is in the first row and second column, so I'm going to use the first row and second column to find it. Okay, so take your fingers. You're in the first row and the second column. So 3 times 7, and then move. So -2 and 1. So 3 times 7 plus -2 times 1. Do you guys see how that works? So you're moving each time. All right, the next one is going to be 3 times -2 plus, you move them, -2 times -1. So that means my top row is 12 minus 10, so 2. 21 minus 2, so 19. 6 plus 2. Yeah, what did I do? Ah, why does it do that? Okay, so 21 minus 2, so 19, and then -6 plus 2, so -4. So I have 2, 19, -4 across the top. Still not. Okay, you guys try the second row. So you guys can figure out the second row. So now you're always going to use the second row with each of the columns. I promise it's not this bad once you guys get used to it. It doesn't take too long after you're used to it. All right, so the next row is going to be 1 times 4. So you're going to have 4 plus 0 times 5, so that'd be 0. So see how you can kind of shortcut it once you see the trick. Next one's going to be 1 times 7 plus 0 times 1, so 7 plus 0. And the last one's going to be 1 times -2, so -2 plus 0 times -1, so plus 0. So you'll have 4, that's a 4, 7, -2. Okay, did you guys get that for second row? All right, last one, you use the third row. So I'm going to have 2 times 4 is 8. 5 times -1 is -5. Next one, I'm going to have 2 times 7 is 14. -1 times 1 is -1. 2 times -2 is negative 4, negative 1 times negative 1 is 1. So you end up with 3, 13, negative 3. Do you guys get it? It's a long process. All right, good. All right, so I have x times w for the next one. Okay, so x times w, so I have 4, 7, negative 2, 5, 1, negative 1. 5, 1, negative 1. Make that a 1. All right, and then w, 3, negative 2, 1, 0, 2, negative 1. Okay, so first see that you can multiply. So I have number of rows, columns, like columns in a house. So I have 2 by 3, and I have 3 rows and 2 columns. So this one is only going to be a 2 by 2 in the end. Okay. Circle the rows in the first one, columns in the second one. That will help you not get off those lines. So as you're moving, you'll remember where you're supposed to stay within. Okay, so the first one I'm going to have 4 times 3 plus, now I move. So I'm going to move right and down, so 7 and 1. And I'm going to move right and down, so negative 2 and 2. I never give myself enough room. Never fails. Okay, did you guys get it? Okay, next spot. So I'm going to have 4 times negative 2 plus 7 times 0, so that will just be 0. And then plus negative 2 times negative 1. Okay, the next spot I'm using the second row and first column to find it. So I'm going to have 5 and 3 are my first spots, so 5 times 3. My second spots are 1 and 1. My third spots are negative 1 and 2. Okay, and then my last spot, I'm going to use the second row, second column. So I have 5 and negative 2 plus 1 and 0, which is just 0, and negative 1 and negative 1. Okay, it's going to take some computing. So I have 12 plus 7, I'll write the intermediate step, minus 4, that's the first one. I'm going to have negative 8 plus 0 plus 2. I'm going to have 15 plus 1 minus 2. And I'm going to have negative 10 plus 0 plus 1. So I have 19 minus 4, so 15. Negative 6, 14, negative 9. Did you guys get that? It's a lot of brain power. Because he says she's very tired. Alright, so let's look at these other ones. So I have x times y. I'm going to guess one of them is going to be not possible, but let's see. 4, 7, negative 2, 5, 1, negative 1. That's a negative 1. Okay. And y is 1, 4, negative 2, 3. Okay, this is a 2 rows by 3 columns. This is a 2 by 2. Do you guys see how C is not possible? Those inside numbers were not the same, so not possible. But can we do the other direction? So 1, 4, negative 2, 3. 4, 7, negative 2, 5, 1, negative 1. Can we do this direction? Yeah, it's a 2 by 2, and it's a 2 by 3. So now those inside numbers are the same, so we're going to end up with a 2 by 3. Okay. You guys getting the hang of this? Do you guys want to try this one on your own too? Okay, so I'll give you a couple seconds. Try it on your own. Okay, so always circle your rows in the first, columns in the second, and that's going to help you so you don't get outside of those little circles. So the first spot, I'm using the first row, first column. So I use this row, this column. So I have 1 times 4 is 4, 4 times 5 is 20. Okay, the next one's going to still be the first row, but now I'm going to move to the second column. So I'm going to have 1 times 7 is 7. Okay, and then move your fingers. 4 times 1 is 4. Don't feel bad about using your fingers to find these, by the way. I still use my fingers to find matrix multiplication. Like, there's really not an easy way to do it. All right, 1 times negative 2 is the next one. So I'm now in the third row. So 1 times negative 2 is negative 2. 4 times negative 1 is negative 4. Okay, now I'm moving to the second row. Second row, first column, so I have negative 2 times 4 is negative 8, 3 times 5 is 15. Second row, second column, so negative 2 times 7 is negative 14, 3 times 1 is 3. And then second row, third column, so negative 2 times negative 2 is 4, 3 times negative 1 is negative 3. So you should end up with 24, 11, negative 6, 7, negative 11, 1. Did you guys get that? Good. All right. It says, note the commutative property does not hold for multiplication. Do you guys notice C is x times y and D is y times x, and you did not get the same results out in the end. Okay. Even if it had been possible, like if I had 2 square matrices times itself, or 2 square matrices times each other, they wouldn't be the same thing. So don't think that you're going to get the same thing out. Okay, a square matrix is a matrix that has the same number of rows as columns, so like a 2 by 2, a 3 by 3, 4 by 4. The multiplicative identity is a square matrix named with the letter I for identity that has all the entries along the main diagonal equal to 1 and all the other entries equal to 0. Okay, what we call the main diagonal is the downwards diagonal. Right there. Those are all 1s. Everything else is 0. Now some people get real lazy and just do big zeros like that, but you don't do that until much later in math, so if you see that, no, that's what that means. Okay, so it looks like that. So 1's down the main diagonal. Do you guys remember what an identity was before? Like when we talked about the multiplicative identity? So if I start with the number 5, what number do I multiply by to get the same number out? So just normal numbers, not matrices. So if I start with 5, what do I multiply by to get 5 out? 1. That's the multiplicative identity. So when you see, when you think of identity, it's what you multiply by to get the exact same thing out. So a lot of people assume that the identity matrix is just 1s everywhere. But it's not. So if I have this example, oops, I'll go with it, and I wanted to get the same number out. So I'm going to go ahead and do this off to the side. Don't write this down. And I thought the identity was 1, 1, 1, 1. Let's say I wanted that. So you don't have to write this in your notes. Let's assume that I thought it was 1, 1, 1, 1. That's how I was going to get 1, 4, 2, negative 3 out again. But once you start computing, you would see 1 times 1 gives you the 1, but then 4 times 1 gives me 4. So my first spot is 5. I'm not getting 1 out like I thought I was going to get. Okay, so that's why we had to use this identity matrix. So let's see what happens. So number one, it says multiply A, which is 1, 4, 2, negative 3, by I. So 1, 0, 0, 1. Rows in the first, columns in the second. I have a 2 by 2 multiplied by a 2 by 2, so I'm going to end up with a 2 by 2. So I have 1 times 1, and then I move over and down, so 4 times 0. I have 1 times 0, so 0, 4 times 1. 2 times 1 is 2, negative 3 times 0. 2 times 0 is 0, 3 times negative 1 is negative 3. So that's how you end up with 1, 4, 2, negative 3. It's the same as what it was before. Whenever you multiply by the identity, you get the same thing out. All right, it works in both directions. Even if I had done IA equals A as well. So whenever you're multiplying by I in either direction, you get the same thing out. Okay, we can also do powers of matrices. So if I want A squared, think about what A squared is. A squared, I'd have 1, 4, 2, negative 3. And I'd have to multiply it by itself, right? Do not write A squared. So this is a big, do not do this on your test because people do it every single year and it's worth 4 points and they miss 3 of them. So don't do this. Do not tell me that A squared is just squaring each individual term. A lot of people will say, oh, it's 1, 16, 4, 9. It's not what that is. So A squared is A times itself, right? So you have to actually multiply it by itself. Okay, so let's see what we get. So I have 1 times 1 is 1, 4 times 2 is 8, 1 times 4 is 4, 4 times negative 3 is negative 12, 2 times 1 is 2, negative 3 times 2 is negative 6, 2 times 4 is 8, negative 3 times negative 3 is 9. So you get 9, negative 8, negative 4, 17. That's what A squared is. So notice how it doesn't look anything, oops, it doesn't look anything like what you thought A squared was going to look like. Is that the last one? Yes. Okay.